Next, we'll talk about installing the HV system. We discussed the design process now. Next, we have a installation process. So installation means, who is taking for installation HVAC or other services. It can be equipment, it can be chiller, it can be pipe. So the contractor will take care of this now, the contracting company. Again, don't get confused. I'm not talking about the main contracting company. I'm talking about the subcontractors. Okay.
Yeah,
Main
depend on client to who will provide it.
yes. Depend as per the scope of work, depend as per the type of project, size of project, etc. Okay.
Yes, sir.
At this level, assume that this contracting company is a subcontracting company who is taking care for the HVAC side only. Okay, if you talk about the main contractor will take care for all the services. Again, that main contractor will provide the job to the subcontractor. Again, the subcontractor, for example, consider HVAC subcontractor.
Yes, sir.
Again, the
Subcontractor,
HVAC subcontractor will provide the job to further subcontractor. Separate contractor for duct side, separate for pipe, separate for
yes, sir.
insulation, separate for welders, etc. So for big project, it's a big project. For big projects, it's a chain. But just at this level, installing the system, assume that I'm talking about HVAC subcontractor. So again, you see, now assume that the architect will have, or the main consultant have all the drawings. All which drawing? The design drawing, or you can consider the contractor. In case of big project, the main consultant will provide the job to the main contractor, and the main contractor will provide the job to the design consultant. Now assume that the design consultant completes the design, and the design drawing from the design consultant is submitting back to whom? Say main contractor. Now the main contractor will provide this drawing to whom? Subcontractor. So assume that this architect at this level is main contractor and providing the information and drawings to the general contracting company, and the general contracting company will provide the drawings to the subcontractor. So again, in subcontractor, you'll find the structural, plumbing, electrical, HVAC, firing, etc. But at this level, we bother about the HVAC, no? So we'll discuss about the
Sir,
HVAC.
just 1 minute.
Yes, please.
So you are saying that architect is main consultant, right? But here
Yes.
again,
You can consider the architect as a main consultant. But again, in main consultant, you'll find the architect and mechanical and electrical team of engineers. For small project, you can assume that architect is a main consultant.
But here you are saying that architect is the main contractor.
No, the main consultant or the owner consultant, and provide the job to the main contractor in case if it is a big project, or else directly he can provide the work to the subcontractors. So depend as per the case. So just focus on the concept. In actual practice, as per the location, as per the type of project, these options may vary. So the point is, the contracting company will take care for, say, installation. So here I'm bothered about this HVAC. So what are the steps involved in installing the HV system that you'll find here? You see, the mechanical or the HVAC contracting company take the HVAC consultant design drawing, also known as engineering or the contract drawing. You can call this a tender drawing. The tender drawing from this consultant to the contractor, we can call that as a tender drawing. Next, you'll find the term IFC also. IFC is to issue for construction, or else we can call the detailed design drawing is IFC, or the what we can call the shop drawing. You can consider IFC, issue for construction. So as per the case. So in this case, you see the mechanical or the HVAC contracting company takes the HVAC consultant design drawing, also known as engineering or contract drawing, or say tender drawing, and then prepare what? Shop drawing, what we discussed at the types of in the types of drawing. Then shop drawings are the detail drawing, larger scale, minimum A2 or A1 sheet. I think as engineer, you know this paper sizes. The normal paper size is A4, na? So generally, if we will not use A4 on site, we know A2 or A1 or A0, or you'll find larger than that. And most commonly, we are using 1:100 scale. Can be 1:50, 1:150, 1:200, depend. But commonly 1:100. And if you're not aware of this scale, don't worry. We'll discuss at the time of dealing with the design. 1:100 means, just I'll give you the idea. In actual practice, it is 100 times, but in drawing, you can find only one time. For example, in drawing 1 mm equal to, in actual practice, 100 mm. Or in drawing 1 feet equal to, in actual practice, is 100 feet. Okay. Because we don't have that much of big sizes of sheet, na? So that reduction is required. So 1:100 means 100 times you're going to reduce. So most commonly scale we are using in actual practice, and on-site scale drawings are required, or else it can be a big issue on site, because if you talk about the duct length, pipe length, etc., they will cut according to the scale in the drawing. They will measure in the scale and they'll multiply with 100. So 100 is a multiplication factor if you're using 1:100 scale. So this is very, very important. So shop drawings are detailed drawing, larger scale, A2 or A1 or A0C with the 1:100 of the HVAC system, which will be necessary for the workers to work on the site. Next, you see the HVAC contracting company has the people who includes sheet metal contractor. Here I'm talking about subcontractors. You see the contractor, the HVAC contractor will hire the subcontractor, or else they may have the team of this workers. So depend as per the case. Some contracting company have their workers on salary basis. So if there is a work or not, they will pay the salary, or else some contracting company, whenever they get the job, they will contact to the subcontractors. So as per the job, they will pay, and after that, then they will not pay. They are not the permanent workers for their contracting company. So as per the case, so if it is a big contracting company, you may find their own team of workers for separate sheet metal, means for ducting, separate pipe fitters for piping, etc. Or else it can be a separate subcontractor, depend as per the requirement or as per the type of company. At this level, I'm assuming that the main contracting company will divide the job to the subcontract company. That subcontractor company, one is a sheet metal contractor who is taking care for this ducting side. Here is an example for the duct. They will fabricate the duct, means making of duct, and they will do the installation for the duct. Next, you see pipe fitters, they will take care for this welding and installation of pipe for this refrigerant side or for chill water side, etc. Then separate insulation contractor who will take care for duct insulation as well as for pipe insulation. At this level, if you don't know insulation, just remember insulation is used to reduce the energy losses. We have a separate topic for insulation and installation in the installation video course. Next, the HVAC contract company also purchase all necessary HVAC machine and the metal. To do this, the engineer first carried out a metal takeoff, nothing but estimation. And in this training program, we are offering this estimation video calls also with the complete tower project. This is also important, and it's a lengthy task. It means, you see, they list all the machine and metal as shown on the drawing with the specification. This is very, very important. You must follow the specification as per the requirement of the project. Okay, and the specification, who is going to decide the specification?
Design engineer.
The consultants. They are taking the responsibility, na? And the specification by the consultant is going to follow by the contracting company. Okay, the contracting company follow the specification, and the specs from this consultant they will provide in the PDF, or we can say PTS, project technical specifications in short. Next, this can be a very involving task. So it's a lengthy task, and you must read the specification, you must read the drawing, you must extract the material. So it's a very lengthy task. That is nothing but metal takeoff. Now assume that the installation is done. The ducting installation is done, piping installation. Just assume that after completing all this, purchasing all this metal, after this metal takeoff and all. So after installation, then what? We require the tab work. Nothing but testing, adjusting, and balancing. Again, the tab work also take care by whom? The contracting company. Or else for very big project, the contracting company may hire a separate company, or they will provide this job to a separate company who's taking care for this, especially for this tab work. For the tab work, we have this separate society. I forgot that name. BE, Bureau of, I forgot that term. We have a separate society for that tab work. Anyone remember that one? Some BEE, or I forgot that one. Okay, I'll get back to you. This you'll find a separate society for this tab work. They are dealing with the research and development for this testing, adjusting, and balancing. I forgot that term. Okay, I've given the instruction. I'll get next. So now you see, after completing the tab work and the quality check, this Q and QC, this is also required. Again, this Q and QC will take care by the contracting company, or else the main consultant or the client may appoint the third party for this Q and QC for additional verification in big project, or else this will take care by the contracting company.
It's IEEE, I think. It's IEEE, the societies.
IEEE. No. One more specifically for this tab work only. I'll get. Now you see, after completion of tab work and quality check, as-built drawing. You know what is as-built drawing? What we discussed now can be prepared as per site modification for final bill and for service and maintenance purpose. Okay. So this is a process for the design and installation in actual practice for HVAC. And if you talk about the other services, the process is almost same. So this was about chapter 2. Sorry, my mistake. We have 2 more topics to discuss: role of a HVAC design engineer and the role of a HVAC execution engineer. I've given in the list. You can go through once. Okay, I'll not explain in the class because this responsibility we'll discuss after a few classes, after getting at least chapter 5. At this level, you will not get anything, this terms and terminology. Because you see, till now, what I explained also, in that also some terms and terminology is new for beginners. I'll hold this this topic. We'll discuss after completing this chapter 5. Okay, with the chapter 5, at least you'll get the idea about the systems, etc. But I request to go through once all these steps. If you're a beginner, you must read at least 2 to 3 times and try to understand the process. Who is consultant, who is contractor, what are the different types of drawing, and who is responsible for what, so that when you in actual practice, when you involve in the contracting side, you'll get the idea how my role is to for installation side. If you involve in the consultant side, you'll get the idea my role is for in the design side. Again, in design side, you'll find the supervision site supervision team, or even in contracting also you'll find the design review team. So for reviewing the design, or to prepare the shop drawing, or to verify the design as per the requirement. Okay, so if you know this, then this will help you for understanding the process, so that and especially the design steps what we discuss, because all these design steps I'm going to expand in the next classes. This is very, very important. Even for entry point of view also, these steps are very, very important. So I'm going to expand all this in detail in the next classes. So any questions online?
Sir, one question.
Yes, please.
It's related to the installation. Okay.
Mm-hmm.
So when I'm working on Revit, at that time I have to define the levels of services as per the coordination point of view. Yes, sir. So when I'm working on Revit, at the time I need to select the levels of services, like above the false ceilings, like plumbing levels, ducting level, cable truss. Okay, so what's the reasons behind that? Cable truss will be above the ting and all these things, and firefighting levels. So can you explain those things?
Yes. So first of all, your question, what you asked at the beginning, Revit.
That is when I'm working on the Revit.
Okay. So you're working on the Revit. So forget about the Revit. So your question is why this cable tray is above this duct, right?
Not only cable trays,
Mm-hmm.
that means how the levels are adjusted,
Mm-hmm.
with the coordination point of view, so that it cannot be clashes with other services.
This is very, very important point. And in building survey chapter 6, we have point number 8 related to this. In detail we'll discuss. I'll give you quick idea. Means you're talking about related to this image, right?
Yeah,
able to see
cable,
this?
cable trays and ducting.
So your question is how to decide this position or this levels?
Not positions, related to levels.
Mm-hmm. So you see, these levels are very, very important, because you see, if issue in one level will affect all the services.
And it's a very difficult job to accommodate. For example, 1 feet false ceilings, 2 ceilings gap, and something like that.
So you see, first of all, in order to decide this, experience is required, and that's the reason in actual practice, this decision is going to take care by the architect or a senior mechanical or electrical engineers, because without experience, you cannot decide this. And you see, above the false ceiling, you'll find the limited clearance, and in that clearance, we need to set all this.
Yes.
So you see, there is no question of reducing this cable tray height, because this is a standard. We cannot work on this. And even this pipes, even this firefighting pipes or distill water pipe or for drainage pipe, we cannot we don't have much scope in that to reduce that, because this is based on the design. So now we have a option for this duct. So remember, this height of the duct we are going to decide as per the available clearance, considering the clearance required for other service. And this is very, very important. And as a HVAC design engineer, this point, as I said, we'll discuss in chapter 6 point number 8. And this is related to, again, duct designing. And if you talk about duct designing, most commonly we are using rectangle duct. It can be oval duct, it can be round duct. We have this advantage and disadvantage, but most commonly rectangle duct. And rectangle means including square. We are not calling separate square category. So remember the height of the duct. If I use the term height, means it is related to rectangle including square. There is no question of height for the round and oval. For that, we have a dia. So forget about round and oval. For rectangle or including square, the height of the duct will decide as per the clearance available, considering the other services required clearance. This is one difference. But again, this is not that much easy, or you cannot, you can, once can take the quick decision. They need some experience. Based on that, you can able to judge, because you see, again, in height of the duct also we have some limitation. Suppose considering all the services, and for the height of the duct, if it gets only 6 inch, we cannot design the duct for 6 inch height, except this exhaust system for small toilet area. And that is different. But for supply duct for air conditioning, 6 inch height means you cannot design this, because if you reduce the height, the width will increase, and we have a limitation aspect factor to maintain this aspect ratio.
Yes.
Okay, but at this level we'll not go in that depth, because the beginners will get confused, or they may get panicked.
I can relate.
Okay, so hope you got the answer to your question.
That means why the firefighting lines are below, and cable trays, and then firefighting lines. I can see that it's.
Now your question is the position, related to position, right?
Yeah.
Okay, so you see, first of all, this cable tray is above the duct, so that if any condensation happen on the duct, will not lead to the short circuit. This is for safety point of view. Okay, this is a standard practice, but in actual practice, you may find the cable tray running below the duct. That because of the coordination issue, because of such side condition. But if you talk about standard practice, the cable tray should be above the false ceiling, because you will not find much maintenance in these cables, and this firefighting pipe below the duct, because for maintenance point of view. But again, in actual practice, you may find the firefighting pipe above the duct also, but it is recommended to run the firefighting pipe below the duct, so that will be easy for maintenance, because the firefighting system used only in case of fire event. Till that time, the proper maintenance is required. They need to check that the condition of the pipe or any leakages, etc.
Sir, another thing is that I can say that in Indian buildings, they'll provide the sleeves in the beams to pass the firefighting lines. So the structural engineer will allow this to penetrate these beams. Is it good practice, or it will weaken the buildings?
Okay, for that also, you're talking about this, right?
It's a vertical slab. It's a vertical sleeves in the but I can see the horizontal sleeves like on the beam. On the
Yeah, you
beams.
see, you'll find the sleeves in the beam, column, or even in slab. So it is allowed, no issue. But at the design stage only. Later, after completing the structure, they will not allow to do the opening or they are not allowed to disturb the structure map. But initially, at the time of design stage, if you coordinate, definitely they will design the structure accordingly, considering this opening for these pipes, because they will design the structure accordingly, because you see, this much of metal is lost now in the structure in this slab. So they will design the slab accordingly. Similarly, for beams and column, if you are looking, if you ask for the pipe sleeves, so they will design the structure according. So at the design stage, yes, it is totally accepted. It's possible, but later opening is not allowed, except some special cases, that too for small.
I can see that all the sprinkler lines passing through the beams only.
And you see, even the chill water pipe also can pass through the beam. But initially, the pipe sleeves are required at the time of the construction only. And the construction means that should be as per the design. Okay, I'll show you this at the time of piping. I'll show you some images. In that, you'll find the pipe sleeves for the chill water, pipe sleeve for this firefighting, even for plumbing. That is accepted, no issue.
And another question, you said that drawings we are maintaining 1:100 drawings, okay?
1:100 scale.
Yes, 1:100 scales. So dimensions will be mentioned in the drawing, right? The shop drawing. So you're saying that multiplications by 100 when we are going to cut the duct. At the side, they're going to measure the drawings, or they will check the dimensions.
You see, for width and height, it is written in the drawing for the duct. But what about length? Length is not mentioned, so they will measure the length.
In the shop drawing, contractor is going to mention the length. I think they're going to mention.
Yeah, you see, in some projects you'll find the length also, but not commonly. Even if it is mentioned, the fabricator. And nowadays in actual practice, you see, means last 5 years back, or say 10 years back, the fabrication on site, but now it is a factory fabricated. Okay. So they must verify. They will verify the drawing with the scale factor. and they must do this, or else what will happen if they not verify means, without that, if they start production for this ducting means that there will be no use, because either you may get length more than the required or less than the required.
Okay, that
So
was
the scale,
manually they are going to check the length with the scale on the paper.
yes, with the scale they will measure. For example, it is written say 100 in the drawing, they will measure. So they must get some 1 but 1 is small, say 1 centimeter, for example. So if 1 centimeter, they will consider hundreds and they will verify. And this is important. And experienced contractor will check the scale when he got the drawing, not only for HVAC, even for other services. Okay, then, thank you.